This is the explanation video of experiment 10. Uh, the aim is to implement ensemble learning techniques, namely random forest and ADA boost for classification problems and evaluate their performance using multiple metrics. The first question is first set of question is for random forest, and the first question is to read the CSV data using the pandas data frame from the CSV file iris slp.csv. And the second question is to process data. Before training the model, we clean the data, handling missing values. Missing values are replaced with the mean of the column. This avoids loss of data and maintains consistency. Label encoding. If the dataset contains categorical value, they are converted onto numerical form using label encoding. Machine learning models require numerical input, so the step is essential. Third question is feature selection x and y. We divide the dataset into x independent variable and dependent variable y, which is the input and the target output. The separation helps the model learn the relationship between input and output. The fourth question is train test fit split. Okay, the data set is divided into training data, usually 70 to 80% used to train the model. The testing data is from 20 to 30%, which is used to evaluate the model. This ensures the model is tested on unseen data, improving reliability. The fifth question is parameter initialization. We define multiple parameter values, n estimators, number of decision tree 50 to 100, and the max depth of each tree 2, 3, or 4, etc. These parameters control model complexity, overfitting or underfitting. Lower depth means a simpler model, higher depth means more complex model. The sixth question is model creation. Mm, we create a multiple random forest models using different parameter combinations. Random forest works as follows. It creates multiple decision trees using random subset of data. Each tree makes a prediction. Final prediction is decided by majority voting. This reduces overfitting and improves accuracy compared to a single decision tree. The performance evaluation. For each model, we calculate accuracy, percentage of correct prediction. Out of predicted positives, how many are actually correct? Recall. Out of actual positives, how many were actually identified? FN score, harmonic mean of precision and recall. And the second, the confusion. Eighth question is confusion matrix. The confusion matrix is used to evaluate a classification result: true positive, true negative, false positive, and false negative. It helps identify where the model is making mistakes. The second set of question is for ADA boost. The first question in this is one to 4 are data preparation, loading the dataset, handling missing values, encoding categorical variables, splitting into training and testing. One, two, three, four. And the fifth question is parameter initialization. N estimators, number of weak learners, and learning rate is the contribution of each model. Uh, we import Adabus classifier. In the sixth question, we are creating model. Models are built sequentially. First model is trained normally. Misclassified data points are given more importance. Next model focuses more on those errors. This process continues improving performance step by step. Each model is called a weak learner, but together they form a stronger model. The seventh question is the performance evaluation. Same evaluation metrics are used: accuracy, precision, recall, and FM score. And this allows comparison between random forest and data boost. And the eighth question is confusion matrix. The confusion matrix is used to analyze the prediction results in detail and understand the classification errors.